Hello and welcome. So we're going to be simplifying the following expression using only positive exponents on our variables, right? So let's kind of take a look at this and figure out how we want to tackle it. There's a couple ways we could, right? There's a exponent on the outside. And reminder on those properties, we could take this exponent on the outside and distribute it to every exponent on the inside, right? In addition, right, we could also start with the inside and work our way out too. Because in the inside, we can see that we have some K's on the top and bottom that are the same. We have some T's top and bottom that are the same. So it's not really going to change the answer. It will not change the final answer. It'll just depend on what steps you want to take first. I personally just like going the easier route. I don't want to bother distributing more than what I have to, so I'm going to simplify the inside first. Now, reminder, if I have a negative exponent, that means that if it's at the top of the fraction, it'll move it down to the bottom of the fraction and turn the exponent positive. So that t to the negative ninth means it's going to go down to the denominator and multiply to whatever is there, right, t to the ninth, and combine with my t to the eighth. Because reminder, if I have something to a power times that same base to the same or different power, they'll add those exponents together. So t to the 8th times t to the ninth will give me a t to the 17th. Right? The 2 on top, that's not going to change. The s to the 6th won't change either. Right? So let's look at those k's. Now, the k's are both positive exponents, which leads to another property that says, oh, hey, if I have, let's make that x to the 7th. If I have the same base, top and bottom, with those exponents, we're going to subtract the exponents from each other. Now, wherever the most of that base is, so for example, here, x to the 7th, there are more x's in the denominator than there are in the numerator. So where the most of that base is going to be where it will be after that subtraction. So 7 minus 4 is 3. And because there's more x's in the bottom, we'll see that x to the 3rd on the bottom after that subtraction. So with our k's here, we have more k's on top. So when I do the subtraction, I'll have my k's on top. So 10 minus 9 gives me 1, so k to the first power, which means I don't have to write the first, it's implied by being there. So we've taken care of the t to the negative ninth, the k to the ninth, right? And that's as good as it gets. And that's still to that negative second exponent, but now instead of having to distribute that to 6 different things, I'm only distributing it to 4 things because I've combined a few of those. Right? Now, a few things additionally to mention is that this 2 also counts as something I'm about to distribute that exponent to, right? If it is inside my parentheses, it is getting that exponent. So when I distribute that negative 2, it distributes to the 2 inside, to the k, to the t, and to the s. It goes to everything in there. The most common mistake I find students make is they do not distribute it to that number. Please distribute it to the number. All right? So 2 to the negative 2. Because it's going to be 1 times negative 2. Exponents to exponents multiplied together. All right, so k to the first, so 1 times negative 2 is negative 2. All right, t to the 17th times negative 2, or raised to the negative second, so 17 times negative 2, we get t to the negative 34th, and s to the negative 12th, because it'll be 6 times negative 2. Right? Now, these negative exponents we just talked about, they move from numerator to denominator, or if you have something negative in the denominator, it'll move it back into the numerator. So we'll notice that all of these have negatives attached. That means that everything in the top is going to move to the bottom. And that means everything in the bottom is going to move to the top. So that means we get t to the 34th, s to the 12th, now in the top of my fraction, and then 2 to the 2nd and k to the 2nd in the denominator. And as soon as something moves, it turns positive, right? And this is only applying to exponent. If I have a -4, that is not the same thing as 1/4. They are not equivalent. Unless I'm saying 4 to the -1st power, in which case that is equivalent. Be careful. We're talking about negatives in exponents specifically. And then my last step would be to simplify. There's no other t's, so no simplification there. Same with the s's, same with the k's, right? But the 2 squared, yeah, that does simplify. That's just 2 times 2, in other words, 4. So my final answer is t to the 34th, s to the 12th, all over 4 times k squared. All right, and that is as simplified as it gets. Thanks for watching.